think the most important thing I want to present today is that biomimicry is a lens. It's a way of viewing the world. And it's becoming much more popular today because the challenges we face are unprecedented. Things like climate change, COVID-19. In resilience literature, they call these wicked problems. And wicked problems are wicked because they have no precedent for how to solve them. We don't have, well, in other words, the thinking that caused them will not be the thinking that's going to solve them. And so I love this quote by Buzz Halling, who says, "The longer one view is held beyond its time, the sharper and more extreme is the surprise, the perception of complexity, and the resulting adjustment." Meaning, the longer we keep thinking the same way, the greater the collapse and release and the potential for evolution. So this is the situation we're in. We're being faced with these wicked problems. We're seeing this glaring contrast between the built and the natural environments. So the thinking that got us into this position are ideas like humans are separate from nature, or this idea that humans can control nature, or that somehow we can resist nature. And humans are unique from the rest of the natural world in that we've been able to harness stored energy in things like fire to make new materials, to re-engineer environments. And so in some ways, we have been successful at separating humans and nature, at controlling nature. But we're seeing that we've gotten to the point now where that gradient that we've created, this separation between nature and humans, has gotten so great that nature is going to take over. Nature abhors a vacuum. And I know this because if we all left the city today, if we all left our cities, what would naturally happen is nature would take over. So this gradient that we've caused is based on the thinking that we've been using to design our cities, design our infrastructure, and design our buildings. So fundamentally, biomimicry is about shifting our perception. It's about evolving our thinking. I'll give you an example. 20 years ago, before I knew about biomimicry, I would have looked at this picture and said, I see some trees. I see some leaves, a little path. I see some roots. But through a biomimetic lens, I now see ancient elders who have long lasted climate change. I see towers that are moving fluids up hundreds of feet without electricity or any mechanical devices. I see towers that are making solar collectors using only water-based chemistry, benign manufacturing, only using a subset of the periodic table of elements. And these solar collectors fall every season, are fully recyclable. I also see in this image a circular economy. There is no such thing as waste in nature. I see a productive ecosystem. There's no such thing as unemployment in an ecosystem. I see towers that are communicating with each other underground, sharing information and resources. Imagine our buildings could do all this. Imagine our buildings could share information and resources. And in a forest, you don't see one tree that's 600 feet above the rest of them. There's this inherent knowledge that when you have a canopy that's intact, when you have all the trees reaching the same height, there's a greater resilience and protection from any environmental perturbations from coming in and disrupting the understory. So a biomimetic lens is seeing that nature has the solutions to design, that nature has the solutions for how to thrive on this planet. And biomimicry invites us into that conversation. By definition, biomimicry is innovation inspired by nature. One of the most classic examples is Velcro, which you see here. And it was invented in the 1940s by a man named George Foussais. He was a Swiss engineer who had those burrs that when you go hiking stick to his pants and stick to his dog's hair. And he finally got fed up with those burrs sticking to his dog's hair, and he took that frustration into fascination and started to see those hooking mechanisms called barbules and realized that those are incredible adhesive strategies. So he took that and just emulated the hook to make Velcro, which is one of the most successful adhesives of our time. Another company I worked with called Whale Power, originally based out of Toronto, were interested in those bumps on the front edge of a humpback whale fin. Curious why the leading edge of an aerodynamic shape is bumpy. Because if you think of cars, you think of boats, you think of planes, you want that smooth fuselage, you want that smooth teardrop shape. So he took this bump technology called tubercles and applied it to a wind turbine blade, and then tested that in a wind tunnel to find that that turbine blade was 20% more efficient. It ran at slower wind speeds and was quieter than a traditional turbine blade. What I love about this example is that it highlights nature's been refining designs over billions of years, testing new solutions to how to thrive on the planet, testing solutions to some of the very problems that we face today, like moving through a fluid, like creating large infrastructure, like creating complex ecosystems and communities, producing food. Nature's done all of this before us. And this is what biomimicry invites us to do, is to learn from this. It's about seeing nature as something not to take from, but something that could teach us. A very cool example is a company called Apeel Science. And they hilariously have copied the skin of fruits to make a new skin for fruits. Food waste is a massive problem. It's a multi-billion-dollar problem. So if we can reduce food waste, we're able to create a solution for a wicked problem. Apeel made this film that's fully biodegradable, fully non-toxic, that they put around the skin of different fruits, whether it's in bananas, oranges, avocados, and they found that they can increase the shelf life dramatically. What's interesting about this company too is it highlights the economics of biomimicry. So yes, you're doing something sustainable, but this company was valuated at $2 billion 2 years ago. It shows that businesses are starting to become interested in biomimicry, to see that there's an economic benefit as well as an environmental. To go on that, there's an architect named Mick Pierce who was challenged with designing a building in Harare, Zimbabwe. And the design brief asked him to not use air conditioning. So he had to design a ventilation system that required no electricity, essentially. What he did is he looked to a local genius, termites, to find a better solution for air handling. What he found is that termite mounds, very much like a tower, kind of stick out of the ground, and they can live in conditions that fluctuate from 40 degrees Celsius to 2 degrees Celsius, all in a 24-hour period. But inside the termite mound, it maintains a constant temperature of 32 degrees Celsius, plus or minus a degree, which means that it's figured out a tunneling and ventilation system, passive ventilation system, that maintains a constant temperature. So Mick understood this and started to research how these termite mounds behave, how they function, and integrated those strategies into his building, which reduced the upfront cost by $3.5 million. By not using air handling and HVAC systems, they were able to reduce costs dramatically. The operating cost was also improved. It uses only 10% of the energy of a building of that size in that environment. With the growth of technology, with the growing interest in sustainability, we're seeing biomimicry applied quite significantly. Architecture is an obvious place. We're seeing it in many buildings. We're seeing it used as a metaphor. We're seeing nature used as a metaphor, but also learning the deeper functions of nature, trying to behave like nature. We're also seeing incredible research happening right now. You know, ideas like learning from electric eels how to make new electrical sources, learning from ants how to build better bridges. If you've ever seen ants, they have this really cool mechanism to work together to cross large spans. Learning from pine cones how to make passive adaptive facades. We're looking at butterfly wings to inspire better solar panels. These are 4 examples of thousands that I could pull from, of biomimetic research and technology that are being developed. And there was a study that showed that in the next 7 years, there's an expected $1.6 trillion of global output in biomimicry-based innovation. This is a rapidly emerging philosophy. It's a practical philosophy, but it's becoming widespread. It's becoming adopted globally. And it really is pushing the paradigm. It's pushing our thinking to show that maybe humans aren't the greatest species on the planet, but that there are other species we can learn from, and that we can learn how to reintegrate into our natural environments. I think what's important to end this first section is to talk about how biomimicry is not a new idea. These are the sketches of Leonardo da Vinci, Antonio Gaudi, who built the church in Barcelona. Both of them were incredible biomimetic thinkers. They looked to nature for design advice. We work a lot with indigenous people here in Canada or Turtle Island, where they learn from Arctic hare's feet to make snowshoes, or learn from polar bears to make igloos. Biomimicry is not a new idea, but it's a new term for an old concept. And this new term is kind of galvanizing a community, and it's helping us remember what we may have forgotten, that nature is the ultimate designer and could teach us really how to thrive on this planet. So I wanted to introduce George and to bring an AI perspective and how it can expand biomimicry.
Thank you, Jamie. So for the sake of this conversation, I want to preface in exactly how Jamie led us to this point about nature being the oldest teacher. It's been here from the beginning, before the beginning, and we as students have been part of the process of learning as much as we can through it, mostly organically. Now, as James said, we're at a point where science allows us to be able to understand and compartmentalize what we're learning from nature and adapt it to our work. And we are at a point in time which is spectacular in that we have the oldest teacher in history with nature and the youngest student in history with AI. And these things are coming together right now. And the two of them will create quite a powerful classroom. What I want to discuss a little bit with you is the idea of design, not as a deliverable, but as a process. How do we designers, how do creatives think? How do we do what we do? So I'll take that from, for example, from an architecture and design perspective, but it can apply to product design, naval design, anything that you can think of, in that design for us is an evolutionary process. What I'm showing you here is the idea that we take a natural environment like a leaf and create a city out of it. And that allows us to be able to think how to solve problems. However, we stop design. We stop design the moment we begin to build. And the moment we start building, design is finished. And then when the nature changes and the world changes around us, the design we did is static. But we have an opportunity now studying natural system biomimicry and so on, for example, studying mushrooms and mycology, in that we can design, for example, a building, a system, a product, that it can keep growing after we're done designing, it can keep growing after we build it, and we can align that with how everything works. For example, we're designing building envelopes that allow us to change as the weather changes, as the conditions change, and so on. So the idea that design does not stop at the beginning of the manufacturing process, but continues, is something that nature's always done. Because if you really speed up the world in a film for the last 1 million years, nothing is ever static. Everything is always evolves and changes. And we need to adapt our design process to be able to continue the design past the fabrication method. And being able to study natural systems, like I said, especially with mushrooms, and what we do with that in building envelopes and in building structures is fantastic, because we can guide that and we can structure that so that our buildings, our products, our designs keep evolving as we need them to, and they don't stop. And you'll see in the next chapter that Jamie's going to introduce, starting with the appropriate code for this, how does that translate to the process we have?
Thank you, George. I think it's important to recognize, studying nature is very complex. And as humans, our brains love to simplify things. They love to create assumptions. And so to help simplify biomimicry a bit, we've broken it up into 3 sections. You can emulate nature's form, which is about looking at the shapes in nature, understanding that nature is refining its shape to fit its function. It's constantly using information and making adaptations. These are impellers that we applied to indoor agriculture, and they mix fluids. We partnered with Pack Scientific, and these impellers are inspired by the Fibonacci spiral that you'll see in a broken seashell. You'll see it when you pull the plug in your bathtub, that vortex that's created. You see it in pine cones or in sunflower seed packaging. But it highlights that nature's shape could teach us something about our design. And in this case, these designs, these impellers, these are the smaller ones, but the 6-inch ones can move 10 million gallons of fluid with the electricity of 2 light bulbs. So they can mix massive amounts of water with very little energy and very little volume. But form-based biomimicry is influential in architecture. When we're creating skins and facades and buildings, it can be influential in also building aerodynamics, cars and planes, or even products as well. It's about recognizing that nature's shapes, like I said, are leveraging the environmental pressures. So it's where we have designed infrastructure to fight nature. And we've been fortunate that we've been able to build robust materials. We design for things like 100-year storm events under this paradigm that we need to resist nature, that we need to fight nature. But fighting nature is very expensive, and nature knows this. And nature knows that materials can be expensive. So use shape before it uses materials. And this is where we can see lots of really interesting information and kind of influence our design. At B+H, we designed a tower in a delta in Vietnam where we looked to form-based biomimicry. We understand that deltas, river systems, are very dynamic. In a delta, in an estuary, the sand is as dynamic as the water. Things are moving. So looking at the local genius, we copied mangroves, and the way that mangrove roots have these kind of spiraling like network of roots and foundations. And that was the influence for our 3-prong foundation for this big tower. We also looked at the structural stability of dragonfly wings and used computational architecture to figure out how to make this structure work, how to make this spiral work with the minimum amount of materials. So form-based biomimicry is an entry point into biomimicry. It's about copying shapes, and it's very sexy because you can see the shape in nature being reflected in the shape of a design. So that story, that translation is easy to see. But it doesn't really improve the sustainability of things. You know, making a more aerodynamic car doesn't take us away from using manufacturing techniques that are very environmentally destructive, or it doesn't take us away from the use of oil as well. So the next level beyond form is emulating nature's process. And that's when you start to see that nature designs and manufactures very differently than humans. You think of spider silk, for example. Spider silk has a strength to weight ratio greater than anything we've ever created as humans. And yet that spider is making that silk at body temperature and body pressure, using only a subset of the periodic table of elements, using only the energy of the sun. And that spider silk is, again, fully recyclable. Often spiders will eat it. You see here honeycombs built with the same kind of benign manufacturing technique, using only a subset of the periodic table of elements, making one of the most structurally sound designs that we know. So process is learning how to copy how nature works, or how nature behaves, and how nature manufactures. We've used this to inspire some of our thinking of how do you bring light in. Like one of the things we learned when we're looking at hospitals and healthcare facilities is how do you bring light in closer to a building or further into a building, knowing that light has a major impact on health improvement and healing. So we looked at polar bear hair, which is a translucent kind of a translucent hair that pulls the light in, and we use that to inspire different ways of thinking about pulling light into a building. When you think of nature's process as well, it doesn't use a lot of energy to cool and heat or to collect water. It's not importing and exporting things. And so in a house that we designed in India, we looked at different ways of passively cooling a building. We looked at elephant skin and the way that elephant skin can trap moisture in its big cracks. And so that when that elephant crosses the hot sun over a long period of time, it doesn't evaporate really quickly. Like you can imagine flat skin, water would evaporate quickly and pull the heat off of the animal. But the cracks kind of prevent that quick evaporation. And so it cools over a longer period of time. And we applied that metaphor to a house where we hooked up this rock facade to the rain harvesting system and trickled water over the rocks to allow this passive cooling to happen, to pull the hot air off the building through evaporation. We too looked at termite mounds and prairie dog holes to figure out how to do better air handling. So the process of using our environment to passively cool. In this case, the prairie dogs have this really simple technique where one side of the mound is higher than the other, so that when the wind goes over top, it creates this laminar flow that starts to create an eddy and a vortex at the lower end, and it'll actually push the air up and create this circulation, this passive circulation, kind of like a vacuum. And in a process as well, you think of nature is constantly circular. There are no wastes in nature, like I said. So we designed a master plan in Saudi Arabia that uses this principle, uses this process of regeneration, of recycling, to create a circular economy, a circular design, where we see that one waste is the product of another opportunity. So there's form-based biomimicry, there's process, and then there's systems-based biomimicry. And this is the deepest and most important, because it invites us to ask, how do we fit into a place? It's about recognizing these deep principles that govern natural ecosystems, things like nature doesn't create waste, or nature builds resiliency through diversity and decentralization. It's about learning these deeper principles and then applying them to our systems so that we can fit into nature. So in everything that we do in our practice, we're not trying to do less harm. We don't believe in this idea of humans doing less harm, because that somehow kind of evokes this thought that humans are a bad species. We're just a very young species. We're still natural, we're still a part of our ecosystem. So our whole philosophy is, how do we become a contribution again to our space? We recognize that our breath feeds trees, our bodies will feed the soil. So how do our buildings feed their ecosystem? And we do this by learning nature's principles and learning how to dance with nature and be a part of nature. There's some really cool work done around this by Neri Oxman and the Oxman Lab, and MIT Media Lab as well, where they're building smaller scale architecture using only benign manufacturing, only using green chemistry. This is a tower that, or this art piece is 3D printed using some of nature's very basic materials. And these materials will actually start to flake off and degrade. So imagine buildings that could change with weather or could change over time. Imagine buildings that could breathe like a lung. Imagine buildings that were built only with basic chemistry. So 96% of nature is made up of 4 different elements: carbon, nitrogen, oxygen, and phosphorus, or hydrogen, sorry. And these towers by Oxman are being 3D printed using those basic building blocks. So this is helping us reimagine how our buildings could fit into a system, how they could be a contribution. And in our work, we do a lot of work with master planning, because that's where I see the greatest opportunity for biomimicry. I know that nature, the most cost-effective thing we could do for climate change is to leave nature alone. Nature's the greatest at carbon sequestration. It's the greatest at green chemistry. It's the greatest at circularity. It on its own is beautiful. And so if we can maintain those ecosystems, we're going to be doing the best that we can for climate change. So master planning, we're trying to figure out, okay, how do we fit into these intact ecosystems? How can we design in a way where our built environments are harmonious with our natural environments? And we use something called the living story as our primary driver. And the living story is understanding, what does the land want to do? If we were to never design in there in the first place, what is nature naturally doing? What are the natural cycles? What are the ecosystems that are emerging? Which organisms want to thrive? What is the ecological succession that's going to take place in this space? If we know that trajectory, if we know where nature wants to go, well, then we can put infrastructure in places more strategically so that we're not fighting nature. we can put it in places where it's actually helping or contributing to those processes. Beyond just trying to figure out where nature wants to go, we also understand, what does nature offer here? Like I said, nature is the greatest model of design and mentor for design, but it's also providing these ecological services. Like I said, it's sequestering carbon, it's producing oxygen, it's reducing noise, it's filtering air and water. It's doing all of these services, and they're doing it for free. So when we do this living story, we want to know where nature's going to go, but we also map out, what is nature offering and what will nature support us in doing. So our master plans are governed by nature, they're led by nature. And this is an award-winning design that we did in Canada, a master plan where we used that philosophy, and we actually measured the ecological performance of the site before we got there. We wanted to know, what is this land doing without us? How much oxygen is it producing? How much CO2? How much nitrogen or NOx and SOx is it absorbing? How much particulate matter is it pulling out of the air? So we measured those parameters before our design, but then we also measured it after our design to see whether we were actually being a contribution. And in this case, our designs are improving carbon sequestration. They're improving oxygen production. They're improving temperature control. We also measured against a non-biomimetic master plan and showed that we have dramatic increases there. But we also measured a fourth one, which is called old growth on this slide. Old growth means, what would happen if that was an old growth forest? If it was just left naturally, that site was left naturally for hundreds of years. And so that's our benchmark. That's where we're trying to achieve. We're trying to get to that place where our buildings are functioning as efficiently as a tree, and our communities are functioning as efficiently as a forest. And so we also measured in this site, we also measured how much water can be captured, how much food can be produced. We want to show that creating a holistic design that integrates nature is a benefit to the community and to the environment. In our final point here, we want to talk about the opportunities. So like I said at the beginning, biomimicry is rapidly emerging as a design philosophy that is transforming our designs and our way of thinking about designs. It's becoming a rapidly hopeful message, recognizing that in these wicked problems, we don't have to make the solutions up. We just have to step outside and create a conversation with nature.
The project that Jamie just showed you, the Lowell project, the one where we actually, it was an award-winning project, and measurements were taken to understand the capacity of nature as a part of the living story, is a very important one. I'll introduce another project that we're involved in. That was also in Canada, and it was a prototype of a farming facility where we had a number of crops growing, and the way agriculture usually works is you grow the crops, you follow certain rules, and then you see what happens in the entire field, and you make adjustments as you need to. But here, we were able to put in sensors that can sense the life or movement of a plant, meaning the growth of a plant, within 4 square centimeters. So we peppered the entire site with sensors that then we connected to a server, and the AI was paying attention on live time what was happening in the field. And what we start to realize is that a couple of things that we would have never been able to know prior to having the AI analyze the data for us is, one, the field doesn't act as a singular mechanism. It acts as a global village of entities. So every plant has its own life, but they all communicate. One of the things that we found very interesting is that as the sun, for example, started coming into the field, of course, the plants that got exposed to the sun first, the leaves turned to face the sun and get the most exposure to the sunlight. But at the same time, they were communicating to the next plant, which was beginning to turn its leaves before the sun went to it. So we realized that network of communication was there, and we were only able to see it when we were able to take a look at all the minute data in millions of sort of input, and have AI be able to, in real time, digest it so we can read it, because our brains work at a certain speed, The natural environment has very simple mechanisms, but billions of them. So it's very hard for us to be able to ascertain what's happening in real time. By the time something happens, it's almost like instant. We don't even realize it, but now we can. AI allows us to compute that really quickly. Now, take that idea, transfer into a city where we can measure building envelope processes, not only from the perspective of environmental sensors, but also from the perspective of human sensors. When you can measure how people feel as the day goes by, as the hour goes by. Jamie and I are working with a very intelligent and very innovative company out of Italy, where they're creating environmental and human sensors to be able to understand the connection or the feedback between the natural environment or the urban environment and the person. And we're seeing that in real time. And the AI is able to compartmentalize the information. And we see, for example, what happens in the morning, what happens in the afternoon. One of the big findings that we found, we're designing we're designing a school in Hanoi, Vietnam. And the data showed us that, you have students in the morning, and then you go to lunch, and then the students in the afternoon don't learn as much. So we always thought, it's kids, they're tired, they had lunch, we can't keep their attention too much. But the data showed that because the students were in the room, after a certain amount of time, the CO2 levels went up to a certain percentage higher, and that dropped the learning capacity of the students. We would not have known that had we not been able to understand the data that were coming to us. We made assumptions before, but now we had real data to be able to tell us what's going on. So we're adjusting the systems to be able to allow the students to work and think and communicate better and learn better. So at the end of the day, I think the quote that Jamie said, that we're not a bad species, we're just a very young one. If you say that about AI, that changes your perception about how that will appear to us going forward and how we can use that to really understand deeper and better and faster nature, so that we can learn, have a better lesson from what we have already available to us to use it and become better at how we design and fabricate our processes.
Right on. Thanks, George. In this final section, we want to talk about biomimicry as being a gateway. It's a doorway into a conversation with nature. Again, the ultimate goal is to blur that contrast between the built and natural environments, to reintegrate humans into nature, and not to perpetuate this separation between the two, because that's what's costing us climate change. The more we resist and fight nature, the greater the energy we need to maintain that separation. So how do we integrate nature back into cities, and how do cities integrate into nature in a harmonious way, in a symbiotic way? I think it starts with biomimicry. You start to realize that nature could teach us something, but then let's also explore beyond biomimicry and look at how nature can integrate into our built environments. This is an interior design project by Spaceman. This is a conceptual design where we create furry habitats made from organic tissue and fur. But it helps us kind of reframe the way that we think about designs and the way that our designs can work with nature. Fur that could shed. Again, Neri Oxman is playing with this interface as well. This is a digital fabrication, but a construction that integrates silkworms. It's called the Silk Pavilion. And so they created this lattice structure and then invited silkworms to come in and be a participant into the design process. So it actually webbed this lattice structure using the silkworms created a silk infrastructure. So we need to push the boundaries between biology and design. What I didn't mention at the very beginning is a big part of what separated humans from the rest of the natural world is our fear of the complexity. It's the fear of the unknown. And nature is complex. It is unknown. It's continued to be unknown. And despite all that we're learning, we're still very ignorant in terms of what's actually happening. And our brain is hardwired to be efficient. It's hardwired to make things simpler, to make things simple. And so we simplify by creating assumptions of how nature works. And we also simplify by building our own environments, engineering them to work and function how we want them to. And that's that separation. So we need to start to allow some uncertainty, allow complexity back into our designs if we're going to create, well, if we're going to really survive as a species. We have to reintegrate into nature.
Yeah, and I 100%, I believe that this is where, so we sort of installed AI within the conversation about mimicry, that AI allows us to be able to dive a little deeper and a little faster into the complexity of nature and be able to understand faster and better how to integrate very, very complex systems within our design process. The sketches you see in front of you are conceptual sketches from a movie called After Earth. It was a science fiction movie. What was really interesting about that movie is they put a lot of effort in the conceptualization of the design, in architecture, product design, and element design that was adaptive. So instead of having, for example, buildings that do one thing for different reasons, had buildings which change based on the sun, based on the on whether people need doors, whether they need windows. But the building was alive, almost like a living organism, a mechanism that was able to house life, but also move on its own and grow. Same thing with the tools. The tools were one tool. You didn't have a hammer and a screw and a knife, but you had a tool that could do all of those because it was quite a bit more adaptive to the use rather than get different tools for specific uses. What AI would really allow us to do is not be a tool that we have it right now. It's very sexy to use AI right now to do better text and better images and better videos and so on. It's fantastic. It's a great tool for that. But eventually AI will be a peer. Eventually AI will be a designer that's sitting beside me on the table on the computer that we're working together with. And as that, it becomes someone who can really translate nature really quickly and really simplify the complexity of it so that we can use it to change the design process. And eventually, just like Jamie mentioned a number of times, is we have to understand that if the teacher is there, we just need to learn the lesson. And we can learn as humans as fast as we can and as well as we can. We believe that AI, with the sheer computational ability of the speed that it has, will be able to allow us to learn fast enough to adapt to create better results. And that means in the future, even the way we see our design process will shift. So I wanted to invite all you creatives in thinking, what does it look like when your work, your creativity, your innovation, your design part of what you do, it does not use AI as a tool, but use AI as a co-student of nature and as a sort of a peer, where we all work together to understand the environment we're in and build the environment we need to live in and through. So it's very exciting times, guys. It's coming. And I think our perception of changing how we work together with AI will also teach us a very, very steep learning curve about nature that we didn't understand before, simply because we can now understand systems and complexity so much better. It's very exciting, super exciting.
I think in juxtaposition to this AI, I want to finish with this slide, which is the root bridges in northern India. There's something like beautifully simple about this. These root bridges are from rubber trees, and they're extending over these ephemeral streams, or these streams that in the high rainy seasons, they become so flooded that people can't cross them. And so over generations and over time, individuals would weave these roots across the river, and the roots would grow, allowing them to cross these rivers, creating these bridges, these natural bridges. And I like this example because it highlights a metaphor that drives my thinking. So the way I see it is that we've been given this beautiful canvas. Nature is already beautiful, but we've been asked to add to it. We've been asked to dance with it. And for many years now, we've been taking the lead and trying to control it and dictate it. But there's an element of dance that requires us to be led by nature. And so as we add to this Picasso, I think for the last couple 100 years, we've been scribbling on it. We've been not understanding the brush strokes of nature, not understanding how to add to the beauty and to the complexity. And these indigenous traditions, these indigenous ideas may hold the secrets for how to dance with nature. Going back to these old ways of working with nature, it could be a lens or a shift for the dominant cultural paradigm to adopt. and to learn how to weave ourselves back into the natural world. Thank you so much for your time and for your questions. I see them coming in already. If you're interested in learning more, biomimicry requires community. It does not work in isolation. You need diverse thinkers together. And so in response, we've developed something called the Biomimicry Commons, which is a community where you can find your niche and find out how to apply biomimicry to that, how to adopt the mindset. And we help build businesses, build products, and build community, and that's most important. We have different services that we offer, but it's all about trying to help people elevate their biomimicry mindset and then build and practice that, that philosophy. So if you're interested, I'd invite you to go to biomimicrycommons.com, and we have different ways of engaging. Other than that, thank you so much for your time. Thank you.
For you guys.
Okay. Thank you so much, Jamie and Georgios, for your incredible presentation. 1 second, let me make this clear so that we can see all of us. Well, give me 1 second. Okay. Okay, here we are. Thank you so much, Jamie and Georgios. It was fascinating to learn so many examples of how we can learn from nature and how we can actually contribute to it. As you said, Jamie, well, you have Biomimicry Commons, so I really hope our participants can also check it out and maybe lose some fear of the unknown with you. And well, as you said, we have a lot of questions, so I think it's better. I was going to read them out loud, but I think as we have so many, it's better for you, Jamie, to open the Q&A box, and you can scroll down and select the ones that you believe there can be more meaningful, or choose your own, because I don't wanna make this call. Okay, so you read them out loud and then answer, and I will copy them in the chat for everyone to be able to read them also, in case it's not clear. Okay, thank you.
Yeah, I think the first question is a good one, which asks, how does the workflow for a biomimicry project differ from others? I get that question a lot because people think it's going to add a big scope to a scope, so people don't want to add in more fees for biomimicry. But what we found is that it's much more integrated than that. And if you integrate biomimicry at the very beginning, even at like the concept, like learning the project, just by having a biomimicry thinker in the work group, you start to weave the metaphors differently. You start to like take the project in a path that it might not have gone down. And it doesn't have to go down a biomimicry path, but at least you're adopting these metaphors along the way. So it adds zero extra time and doesn't add any extra scope. And that's what we do at B+H, is we integrate biomimicry into the project. So it's not like an add-on, which helps it make a more efficient process and not something that's intimidating to a client. So Thomas had a good question about the Jevons paradox, this idea that as technology becomes more efficient and cheaper, it's going to drive up the consumption and use of it and demand. This is the beauty about biomimicry, though, is that there's no such thing as that paradox in nature, in that there's no waste. And so if you have no waste, there's no problem about building more technologies or more products. Really think of, like, when I think of the future of biomimicry, I think of a forest, I think of an ecosystem, and every spring it's generating new products, tons of new products. It's creating new food sources. It's creating, like, new towers. And it's also disposing of old products and old towers in the fall. Like, you have this massive consumption and massive degradation and decline. And that's the beauty, is when we get to the point where our manufacturing is fully biomimetic, we're going to be making materials that are using only 4 elements on the periodic table. And if it does so, it's easier to decompose and easier to deconstruct and to be reused in a different form. Nature naturally creates conditions conducive to more life. It creates more life. And it's doing so on a thermodynamic scale of trying to dissipate the sun's energy. So as long as the sun's around, nature's creating, and it's using those creations to help stabilize our environment. So there's no problem. But yes, for now, there are technologies that require, harsh manufacturing and toxic chemicals. But every time we iterate on these biomimicry technologies, we're going to get closer to the green chemistry and to the real symbiosis that nature has. Hopefully that gives you a clear answer.
I can take the next question by Edgar real quickly is about biomimicry was discovered since Gaudi and Leonardo. Why wasn't it used since then? It's been used since the beginning. Humans have learned how nature works, and we use that all the time. It wasn't discovered then. Now we have a name for it because there's a science behind it. There's also a process that allows us to not evolutionize what we do, but also remember what we used to do to bring it back and reintegrate it. I'll give you an example. When Gaudi designed La Sagrada Familia in Spain, he wanted to understand how to build the most efficient structure for all the parabolic towers that he wanted to design, very organic. He was not an engineer. He was a mason. He was not an architect. He was a mason. But what he did do is he realized that gravity and anti-gravity are the two things that will really make this work. So he took strings and chains and let them hang upside down to the shape that he wanted La Sagrada to be. And gravity gave him that exact parabolic curve that he needed to create it. So then when he inverted it, that became the structure and the shape for the church. And actually, if you go into the church, the strings that he used to create that are hanging as the light fixtures in the main hall. So we understood how nature works from the beginning. Now we have a name for it. Somehow our processes sort of veered away from that in, as James said before, fighting nature. So now biomimicry has a sort of clear standing where we can come back and say, remember how things work, and pay attention, and we'll reintegrate it and re-nature the process that we have in fabrication and design and bring it back to what we've always known from the beginning.
Thank you, George. Man, there's a lot of good questions in here. I don't think we're going to get to them all, but please feel free to reach out to us and engage in these conversations. There's a couple on indigeneity that I think would be good to address. Specifically one about appropriation. And I really appreciate that question because I do struggle with that as a settler, as a colonizer. And we have many projects with Indigenous communities. Now, the one thing I heard, Robin Wall-Kimmerer is an author who talks about biomimicry and Indigenous knowledge. She is Indigenous to North America or Turtle Island. And she says that appropriation is important to recognize, but is somewhat subdued when you reference and acknowledge the source of the information. So you don't take it on as your own. You don't actually appropriate it. You identify who the source is or what the source is. And I think that's in parallel with biomimicry. Is like we're constantly celebrating the genius of nature. And when we work with Indigenous communities, it's the same kind of mentality that we celebrate the genius of the indigeneity and the Indigenous people. And we're working on a project right now with the Métis Nation of Alberta, and what I'm finding is that they have this biomimetic lens, and so it's their project, and I am just helping kind of communicate things. But it's a very much a partnership, and I'm noticing it as it's the Indigenous knowledge that is driving these designs. So it's not really biomimicry. I'm learning more from them, definitely, than they're learning from me, but this is an area I want to keep exploring, is this relationship between Indigenous knowledge and biomimicry, and how to do it in a way that's respectful and honoring these traditional knowledge systems. But thank you for that question. Many people asked about how, sorry, go ahead, George.
No, I'm saying there's so many good questions. I want to ask them all, but I know we don't have time. But like Jamie said, please reach out and we'll get back and answer everything that we came back to you. There's so many great thoughts you guys put out.
there's a few questions on which tools we use for measuring the ecological performance. One is called the EASY tool. There's also a new one called Ecosystem Intelligence that I think ERA or Ecosystem Intelligence, if you look it up, and there are emerging tools that are coming out.
There's a couple of questions also about whether biomimetic architecture and biomimicry makes sense in terms of economy, in terms of economy of scale for architecture and buildings. So I would, this is a topic that comes up with all our clients or developers and everybody we talk about how to move forward. Realize that the economic reality of our architectural building infrastructure, meaning the fabrication and construction industry, is based on a way of designing that we've accumulated over the last couple of 100 years. The question is not whether biomimicry makes sense in the manufacturing we do now. The question is, will biomimicry allow us and nature allow us to learn how to manufacture better, which eventually will become quite a bit more economic, not in terms of the economy of scale for fabrication, but also the economy of scale for recycling. One of the biggest components or the biggest dirts, I guess, of our construction method is the waste. And the way we fabricate right now, the waste is not as recyclable as I would like it to be in many different ways. But as Jamie said, nature recycles everything. Everything moves into a circle and it keeps going, and it keeps being reused in a number of different ways. If we simplify the way we design and the way we build, we're going to simplify the way we extricate process and the way we recycle. So there's going to be a shift. It has to be a shift to be able to understand how to do it better. But once we do it better, the economy of scale is going to skyrocket. And this is the understanding from the people who see, the next phase 2, phase 3, phase 4 of our construction process, and that once we learn how to do it more naturally, it'll become quite more of a streamlined economic process to build and maintain.
Jamie and George, maybe you can answer one last question. We still have 1-2 more minutes, and then I will ask them to reach you at your website. I believe there is a template where they can submit their questions, right?
Yes, yeah, they can. Yeah, you can reach out to us.
Okay, so please choose the last question, and I will post the website so that they can also submit the questions there.
There's one question further down. It says, it feels like many of the processes using biomimicry are just reinterpretations of the old humans as separate from nature ways of thinking, in that they just need to be packaged, sold, and profitable. How do you see the viability of biomimicry working within a capitalist mindset? I think this is interesting because capitalism is fundamentally based on scarcity. It's like not having enough. And that's what seems to drive our economies, is this belief we don't have enough and that we need more. But nature is based on abundance. And working with indigenous communities, especially I've noticed in Kauai, where I'm working on a project right now, the abundance mindset is a systems mindset. It's about recognizing the interconnectedness of things and the importance of collaboration and working together. So I think the way that we see biomimicry being bought and sold now is just because it's being built on this capitalist mindset. But I think the deeper we go into a biomimicry conversation, we're going to start to see that ultimate ecological resilience is the resilience of all. It's the abundance mindset. It's recognizing currency not as money, but maybe as air or as services. And I think with the technologies that are coming out, like blockchain, different Internet of Things technology, we're starting to see the economy shift, and we're starting to see the importance of resilience through an ecological lens. And I think we will see, I think in Kauai, this is a great example. Kauai, when led by indigenous people, was so abundant. They only took, off the top, they say they take the top of the basket, not the whole basket. and they had discipline around that. And they knew that living on an island, you have to work together. And I think that philosophy can be translated to our globe. We're all on this planet, and it's so far the only one we have. So how do we work for the greatest, the greater good and the success of all of us? An ecosystem works because it's all working. An ecosystem will strive for diversity, and in that diversity, it thrives. So I think, to answer your question bluntly, we're starting within the capitalist mindset because that's how we think. And I say we with quotations, but as we go deeper into our conversation with nature, we will see that capitalism and scarcity mindset is not how it works and not how resilience is based on this planet. So hopefully that gives you an idea of our thoughts. I think that's it.
Okay. Thank you so much, both of you, Jamie and Georgios. It was a fascinating lecture. Thank you so much also for all the participants. You were super active with all your questions. I'm sorry we couldn't answer all of them live, but we will figure out a way to get back to all of you. You already have their website, Biomimicry Commons, so you can reach them directly. And that's it. I just wanted to remind all of you that our next session is next Saturday with Jennifer Duran from AI X Architects. We will have a workshop on AI. So I just remind you to download Discord and Midjourney and open an account so you can enjoy the session this weekend. Thank you so much, Jamie, Georgios.
Thank you.
you.
Bye-bye.
Thanks, everyone.
Bye.